Okay. If we have, and just as a general approach to mathematics, something that is beneficial to keep in mind. If you have one fraction with a variable in the denominator, make everything a fraction. Even if it's not, like even for, in this case, plus 7, make it a fraction. Because what we talked about is find the lowest common denominator and multiply it through to clear out all the fractions. Well, here's this denominator, here's this denominator, and here's this denominator, right? So x plus 4 is the exact same thing over here. So I don't need to say, when we ask the question, you know, what's missing, all right? Before, when these were different, sorry, I gotta go way up. When these were different, the common denominator was the product of these two denominators. I don't need to do that here because they're exactly the same. But I don't have the same denominator here, so not that it matters really because the denominator is 1, I'd have to multiply those together. So my common denominator in this case is x plus 4. So I'm taking x plus 4 and multiplying it by everything. I'm taking x plus 4 and multiplying it here. Now this is a binomial. I know it doesn't look like it, but it is. I've got one term here in this fraction, and then I've got the 7. Okay, so I'm taking x plus 4 and I'm multiplying it times this fraction to clear the x plus 4, but I also have to multiply x plus 4 times 7. So it's not like this just goes away and I have 4 plus 7. That's not true. I have to multiply both of these terms by x plus 4. Now over here on the left, it's pretty simple. The x plus 4s are going to cancel, leaving me with just the numerator. But as we said here, we're taking x plus 4, we're canceling it with this, and that's going to leave us a 4 in that place, plus I have to take x plus 4 times this fraction as well, which is just that 7. I don't need to write it as 7 over 1. I only wrote that 1 just to emphasize the point of everything being a fraction. But I have to multiply the x plus 4 times this fraction and times this fraction. It's canceling here. It is not canceling here. That's why I have to include it in that product. I have to write it out. So I have x plus 8 equals 4 plus. I have to distribute before I can add. This cannot be 11. Multiplication takes precedence over addition, so you have to distribute before you add. So we have 7x plus 28. Let's move this x over. We have 32 as a combined value of these two constants. I'm going to subtract that over to here. So I have negative 24 equals 6x. When I move this x over, that's 6x. 32, and I have to subtract that from both sides, I get negative 24. When I divide by 6, I get x equals negative 4. Now again, this hasn't happened yet. But if I do this and just march on, I'm ignoring the possibility of this turning these denominators into 0, and this is the first time it's come up. But the value that I got through doing the math, through doing all of my solving, I got x equals negative 4. The problem is these denominators both started out as x plus 4. So if you take this and you plug it in here, negative 4 plus 4 equals 0. That's a no-no. You can't have 0 in the denominator of a fraction. Even if your math is solid, this happens in other instances. This happens with logarithms. Okay, this happens with, when you get into pre-calc, we do this with limits. It happens a lot. Okay? So we have to say here, no solution. Even though we want to say our math is good, we can't use that as our solution. We have to say no solution. Sometimes this is the symbol that gets used. A 0 with a line through it. That means the empty set. All right? When you have rational equations, you have to account for those denominators.